Hello, my name is Corey Greason. This is my thesis for Central Magnet School. Falls are a big problem in the U.S. 1 in 4 adults over the age of 65 will have one every year. This leads to 29 million falls, 3 million emergency department visits, 800,000 hospitalizations, and then 28,000 deaths. This is the leading cause of death by injury in older adults, and it totals up $31 billion in Medicare costs for the U.S. government. Additionally, patients can sometimes suffer from a condition called HAD, or hospital-associated deconditioning. This is a special kind of muscle atrophy that is a decline in patients following an acute hospitalization, such as falls. The sedentary typical procedure of trying to heal these people usually causes the atrophy and then later puts them at more risk of more injuries. My mother is a physical therapist and has to deal with a lot of these patients on a regular basis. This is why it's important to me and an important problem to solve. She originally brought to my attention. As a physical therapist, their job is to care for these elderly patients and make sure they can live independently and be functional. Typical treatments would be strength training, aerobic training, flexibility training, and balance training. But these aren't always able to be done. Just like we've seen this year, in the past year, COVID-19 has put a big damper on things. Patients aren't able to leave their rooms, and because of this, therapists have to come to them. And it's limiting what they can bring with them and limiting the care they can provide. Through my research, I've found that PRT, progressive resistance training, allows the best training for functional and strength, as well as just strength training in general. And so that's what I wanted to focus on in this thesis. And then for my problem statement, my goal for this thesis was to create a device that effectively provided strength training, was cleanable, transportable, and affordable. Those are the big things. Had to be cleanable because of the whole problem where this arose from was COVID-19. Needed to be transportable to go room to room, as that's another big thing. If patients are going to be quarantined with COVID-19 or even before this with bacterial conditions such as C. diff, the therapist has to be able to get in there and do the therapy with proper equipment. Has to be affordable. There's similar devices out there right now, but they cost exorbitant amounts of money. The centers just can't warrant to buy these devices for their therapists. As I mentioned earlier, there are some solutions out there now, but not a lot. One such example is the NeuroGym sit-to-stand trainer. This device is similar in function to what my final product ended up being. It uses a weight stack to provide a positive force that pulls the patient into the standing position and allows them to train standing with progressive amounts of weight. This allows the patients to perform standing and get better at that, as well as just increasing strength at a progressive rate. Something through my research I found to be pretty useful. The rest of these examples are going to be more so suited to just typical strength training and or functional training. Again, there wasn't very much, there was only one other device that did exactly what my thesis will do. So then there's therapist-assisted stands. This is a less finite way of doing the same thing in mine and the NeuroGym trainers will do. You can put a strap around a patient and help them pull them into the stand. This is okay pre-COVID. I think post-COVID, being that close to a patient, and then it's not necessarily the safest thing to do. Additionally, it's just not finite. You can't control how much force you're putting into the patient and how much. You can't write that down and go back and try to do more and more each time. Another thing is stairs. I know my mother and other therapists will typically have patients try to walk stairs. This is important because patients are going to encounter stairs in their day-to-day life, and knowing how to navigate them and being able to navigate them is very important in their function. This again, with stairs, you're not really able to just bring stairs into a room, but you can bring steps. Resistance bikes are their functional trainer. They allow strength to be built as well as aerobic. You're able to do this both at the same time, increase the patient's strength, but it's limited in its use. You can't just bring a resistance bike with you everywhere you go. Another interesting solution is these functional games that have come about in the last 5 or so years. We were able to kind of use augmented reality or something similar to have the patients play games, or they're encouraged to stand or move their feet in certain directions to play the game. This has been, I think, a good successor in increasing the function of patients and just giving them more variety to do, and something that should definitely be used. But again, you're not able to just bring that into a patient's room. And the last thing I'll include in this list that aids with function is assisted walking. Assisted walking is such as just a patient's walking with the help of a therapist or with a walker. Again, you're going to encounter walking in your day-to-day life, so being able to do it's important. But if you're not able to leave your room, it's hard to just walk, do pacing in your room. So finding other ways to increase that strength and functionality are very important. All these solutions I mentioned do indeed help with function and with strength, but most of them are just not feasible to do in a room, such as the neuro gym, the functional games, the resistance bikes. And with COVID, you can't even really do the therapist-assisted stands. Like I mentioned, some of these are already exorbitantly priced. Like the neuro gym sit-stand trainer costs $5,000 unshipped. So that would be another cost as it comes fully assembled and it's fairly heavy. That's just an expensive cost, and because of its limited function of just the sit-to-stand aspect, it's not really worth it to each center to purchase that device. And same thing with like a resistance bike or functional games. These are both expensive devices that are limited in use, less so being the functional games. And so this just backs up my original problem statement of trying to have an effective yet affordable device that all centers could be able to purchase. For the next part of this video, I'm going to go into more of my designing and conceptual parts of it. For my materials, I did a decent amount of research on what kind of steel I would need to use in order to support all the weights. I ended up deciding on 14 gauge 2x2 inch square tubing. For multiple reasons. One, obviously, I knew it's strong enough to withhold any forces I could put on it. Additionally, it is what my local metal supplier had in stock and would carry. Had about that 2x2 inch size that I was looking for. Through talking with my mentor and my engineering teacher, I went the route of using gussets to build it. This way I could disassemble it if I needed to, and if this were to be commercially viable, be able to ship it disassembled to have cheaper shipping costs. So I was able to CAD those on CAD and then send them to a local person in town who had them plasma cut out for me to use and build with. For the knee pad, I used just wood, and then I was able to use some harder, dense foam and then wrap that with a vinyl wrap that would allow it to be cleaned. For each part of the thesis, my goal was that it's easily able to be wiped without being damaged by liquid chemicals that you would use to wipe it. And for my pulleys and all the weight-bearing elements, I made sure that their working loads were at least twice of what I believed would be throughout the force throughout the system. And this is my design 1. I liked most of the parts of my first design, including the knee pad, the height of the device, and the bracing that I used. It's also my first time I tried putting the gussets onto a CAD assembly. However, after talking to my mentor, it was just far too long and the cabinet would be way too heavy to be considered transportable, one of my main goals. So I scratched this and went back and redesigned it for my second design. I like the second design a lot. It ended up being my working prototype when I went into the prototyping stage. However, it did have its flaws, but those would be fixed in my prototype. For this one, I changed the size of it. I decreased it from 6 feet to closer to 4 feet, trying to just increase its transportability into each patient's room. That would also decrease the overall weight of the device. I had yet to CAD the casters and the weight stack the design into this because I planned on doing those just in the prototype. So you'll see those in the next picture, which is the prototype. In the prototype, the first thing you'll probably notice is that it doesn't have a handlebar. After discussing with my mentor, we determined that the handlebar was more of a non-essential part because I was limited on how much I could build. One of my goals, like I said earlier, was to use the gussets and make it completely disassemblable and adjust the gussets and the tubing. In order to do that, I wouldn't be able to weld, and as I don't even own a welder, doing the handlebar would have been nearly impossible, so I left it off. And ultimately, the end goal of using this device would be to wean yourself off of the assistments anyways. So not having the handlebar isn't really that big of a deal if the goal is to not get you to use it anyways. You'll also notice that the weight stack has been realized. For the weight stack, I use 2 vertical rods as guide rods with a plate and pipe through the middle that has a hitch pin assembly. That hitch pin is going to allow the pulley system to pull directly up from the center mass of the weights and not have any rocking that I don't want. Because I have the crossbar with the knee pad attaches, I also had to put in 2 8-inch spacers on the guide rod so it never went fully down or else it just wouldn't work. One of the last things you probably realize that the cabinet design changed from the original CAD to my prototype. I did this after discussing with my mentor. We decided that not having cabinet doors would both save weight, also make it more functional. I went to the local store and purchased the plastic cabinets that would give me very lightweight drawers that would increase storage as well as keeping the weight down. And lastly, you'll see that it's all painted and sealed. I used a hammer paint that's easily cleanable, very tough, and I also used polyurethane on the cabinet. Both of these should allow you just be able to wipe the thing down with a liquid chemical like a Clorox wipe or bleach, similarly with the vinyl wrap on the knee pad. During the construction process, I did have some issues, but I learned a lot along the way. For all the prototyping, I really never had to redesign anything, but if I could go back, I would definitely change some things. I had to drill individually each hole that the gussets went through, and if I would go back, I might use a welder to weld on at least half of them. This would allow the assembly process to go a lot more smooth, a lot smoother. While still keeping that low profile boxing ability that I'd like. In addition to the gussets, they added a lot more weight than I originally intended. So if I could go back, I might use a smaller gauge instead of the 11 gauge steel that I used for that. The 11 gauge seems to be more of an overkill to prevent any kind of shearing and just add strength, which it does, but it's a little too much that I need. And they add like 60 pounds to the whole device. Something I don't really need there. The last thing I would change in another prototype would be to try to put the mass more in the center that would allow it to be easily removed. One of the solutions I have now is to put a plywood board there to store the weights, to put it in the center. But just designing it that way from the beginning would make everything so much easier and easier to move, even if it is kind of large. As that's going to be one of the most common complaints later on. So this is the prototype. For this, I'm just going to do a little walk around of the device and each of its parts. I guess the first thing I'll start with is the adjustable resistance bands. So here we have a resistance band, and there's another attachment point on this. I just don't have a band right now. And we'll just assemble this, and you can move the band up and down on both sides. There's a lot of there, but it's a lot of versatile more versatility in doing exercises. More versatility in doing exercises because they can change the height at which the force is coming from. This is the weight stack here, and I'll do a more in-depth look at that in a little bit. Coming around to this side, we have our cabinet where you can store the weights at the bottom, manage drawer. On this side, as well as the other side, offers more storage for each therapist. The top and the whole cabinet's finished with polyurethane, so it's very cleanable, and the device itself is painted with a hammer paint, again very cleanable. This is a good place you can store the weights, and also it's pretty close to the center of mass, but this is how easy it is to move. It's incredibly simple, and this angle gives you a better view with my limited extrusions and the adjustable low resistance bands here, and how that works. It's also my pulley system. Now I need to change the angle once more. And then so you see our weight stack here. The weight stack, like I said earlier, works in this hitch and pin assembly, here being the pin. And the metal it goes into is this piece here. It's just a piece of sheet metal that I cut a whole lot of and put some pipes through. This allows the pin to stick all the way through, or the hitch to stick all the way through, and when the pin goes through, it's locked on. And now to load weights, I'll show you that. So for this demonstration, I'm only going to load 30 pounds. So what I'm going to do is take these weights here. Here's 20. And you just set that over the top of that pipe. Here's another 10. And then from here, you want to have your pen and take this, stick it through, and stick this pin. Come on this side, as you can see. Take this pin and stick it in the hole. Ultimately, so it wouldn't be the best design for a weight stack, but I believe it works as a proof of concept for this thesis. And yeah. So next I want to show the standing capabilities, but I don't have the proper harness to do that right now. But I have it filmed from a month ago, so I'm going to add that clip into this video. Push it in. Now you're good. Next part, you have this harness here. It's going to go around your glutes. Obviously, you would have a therapist doing this in a real setting. However, for this, we are not in that setting. Ugh. So you have this hook here, it goes attaching here. I plan to make this a little stronger connection. Add safety. Now you're gonna pull the weight up. This loads all the forces. Now we have our force pulling down, and we can practice some stance. And once you're done, kind of just you push the button here, let all the tension out of the rope, and you can unhook, unbuckle, and that's that. One thing I'd like to add as a kind of disclaimer to that last clip is that all the actions that I did in a real setting would have been done by a therapist, not by the actual patient. Yeah. So to continue, I'll go with my methodology in the study of my actual thesis, the testing. Originally, I had planned on having the therapist use my device on patients. However, kind of as time went on, it became impossible to do. The center I used wouldn't allow it just for legal problems, which I totally understand. So what ended up happening is that each therapist used it among themselves and individually, and then recorded it on a survey for me. I left it at the center for around 2 to 3 weeks, and then in that time, each therapist used it. I think a total of 8 to 9 therapists actually used my device, and they answered a survey I had given them. On the survey, it asked them to rate the effectiveness, the cleanability, and the transportability of the device. The results of that were that each therapist rated the effectiveness 5, which bodes well for my research question. As one of the main goals was to actually have the device work. The next question was cleanability, and all but one therapist rated that a 5, and the one that didn't rated that a 4. Again, bodes well for my research question. And lastly was transportability. This one a little bit more mixed, with the average coming around more to a 4, but some still rated 5, some still rated a 3, most rated a 4. Even though this wasn't as positive as the other ones, it's still a positive result, and I think still proves my research question, proves that I accomplished that goal. Going back to the personnel I chose, I think having therapists test the device is almost as good as having the patients, because they're knowledgeable and actually are performing the therapy themselves. So having them do it is good. Now on to the next part of the survey. This is more qualitative and where I had the therapists write answers in on the survey. I asked them what parts about the device they would change, and a lot of them answered stuff about the movability. So whether that mean make the device lighter, easier to move. One I think even said more cleanable, but I took a lot of those into consideration, and I've kind of thought of some ways that I could change my device to make it better. The next question I asked was which parts of the device they liked the most, and a lot of them answered the effectiveness of the device. They liked the versatility of the device and all of its components. One therapist said they liked the transportability of the device, being able to move it back and forth, but the most common response is the versatility and just the sheer amount of exercise you can do. And along the same lines, in the videos I've only shown the standing aspect of the device. However, through their testing, they were able to find a lot other exercises that are able to be done with the same device and same components, which is another reason why it's good to have the therapist use the device. The last question I asked them was 2 parts. The first part being, would they recommend this device to their center? And all of them said yes, which I think, again, is pretty good for a research question, as having a device that's accessible to centers. And along that, I asked at what price point. Asking the therapist what price point gives the device a value to that therapist, and a value that they'd be willing to pay. The average answer was around $1,500, and in total cost, I only spent, the device only costs $500. So including labor, I would still be able to make a profit if this was a commercial product. Some of the limitations of this study were my building experience and construction knowledge. As I didn't know how to weld. I had to use a bolt assembly to assemble the whole thing, which I decided was a good route to go in the end, but it kind of took welding out of the question for me. Another limitation was just the tools I had available. I had to hand drill almost all of the holes for this device, and having something better would have made the final product a little cleaner. And lastly, one of the biggest limitations of this study was my research group. I wasn't able to use patients like I originally wanted, which kind of limited the scope of my research, but I was able to gain valuable information from each therapist about price and the usability of the device. For the implications, I think the biggest implication for this thesis is there's other routes for therapy, and sometimes there's better ones. A device like this device or a device like this, I think show promise that we can decrease falls, and we can make geriatric therapy better. And I think that's the biggest implication. At an affordable cost as well. Health care equipment is very expensive. And then the last thing I'm going to say for this video is plans for future study and what they should be. I believe if there were any future studies, making sure I get the proper licenses in order to have the device actually used by patients is key. Any kind of market research is going to have patients use the device to understand the effectiveness of the device on patients as compared to other devices out there. For this research, I wasn't able to find any control groups or any actual testing of whether my device is better than traditional methods, even if the therapists seem to think it might. So that's the key for future plans. And I want to end this video off by thanking you for your time and watching it. And yes, thank you.